So cool, let's start with the next talk. I'll be giving a quick introduction to our next speaker. Up next, we have Dr. Megan Squire, who is a Deputy Director of Data Analytics and OSINT at the Southern Poverty Law Center. Now, she has a background as a computer scientist, and she is using it to build SPLCs, a new data lab, which is used to track and expose networks of hate and extremism. We have a true superwoman over here. She is the author of 2 books on data cleaning and data mining, and has over 50 peer-reviewed article and book chapters, including several Best Paper awards for her work in tracing extremism, online fundraising, and cryptocurrency. The topic that she will be covering today is tapping the OSINT potential of Telegram. Now we all know that, how many of us use Telegram over here? Wow. So we all know that whenever you go across a channel, there is another feature to see similar channels, right? So what Megan and her team did is that they're going to release a new tool over here at DEFCON where they will analyze this similar channel feature. And in this process, she will then show how to use social network analysis and techniques to uncover previously hidden relationships between channels and the platform. Right, so here there's a lot of OSINT coming into picture. Please give it up for Megan. Dr. Megan.
I'm short, so I'm going to move that down. Also, I have a quiet voice, so if you can't hear me, just go like this and I'll start yelling. So I'm Megan, and this is my talk about Telegram. So I work for the Southern Poverty Law Center, as mentioned, and I'm in the Intelligence Project. As an organization, we're like a civil rights org, we're a nonprofit, and within the Intelligence Project, we have a unit called the Data Lab. And so I'm in charge of that, and what we do is create data-driven intelligence about how hate and extremism works, mostly in the US, right? But sometimes we have an international context as well. And so we produce some of the products you see there, like our hate map and different network maps, to try to explain how this phenomenon works. Telegram's one of our most common data sources that we use like pretty much constantly because it's so highly used by these groups and individuals that we're studying. And you probably know, a lot of hands went up when he asked how many people were using Telegram. So you probably know that it's a messaging app, right, primarily. It has chats. You can talk person to person on there. There's some level of encryption, although it's debated how strong or how good that is. There's also group chatting, things like that. Telegram also has broadcast-style channels, so you can see the screenshot there of InfoWars. It's like a disinformation network in the US, and that's an example of a group channel. You can see that there's like postings, and people can click like on them or use different emojis. Also over on the right-hand side, you can see like there's different files, uploads, and voice messaging, videos, and stuff like that. So it's a pretty full-featured application. It has a lot of things that make it appealing to anyone, right? But also those same features are very appealing to the groups and individuals, the adversaries that we study. Recently, Telegram also launched a mini app store, so you can make apps now inside the product. In this way, it's kind of like a real platform, right? It's a platform upon which they want you to build your own software and stuff. So it's pretty full-featured. And one of my favorite things about Telegram is that it has a very robust API. So we can program to it, right, and pull data out. A lot of social media apps are like that, but Telegram has more than most of them, and it's a little bit more more giving, right? It's a little bit friendlier to people like us that want to study it. So some of the OSINT opportunities you might have already heard about, or these are pretty well covered, so I'm not going to spend too much time here. I want to get to the new stuff that's a little more juicy, right? But some of the things that people use Telegram and OSINT for would be its API, as I mentioned, very robust, lots of features. You can get a lot out of there. Not everything, but a lot of things. It's got a lot of opportunity for searching for users and exposure that way, a lot of exposure opportunities. In terms of like putting in a phone number, you can find the profile, maybe you're in the same group with the person, that sort of stuff. People have usernames on there, so that's an opportunity, profile pictures, etc. There's also geolocation opportunities in Telegram. Now this is configurable through security settings, but those are labyrinthine and very complicated, so there's a lot of opportunity for people to make mistakes, which can be good, right? If that's the approach that you're interested in them taking. Sometimes it's hard for us though to protect our own selves, but geolocation is one of the options that a lot of ink has been spilled about this one. You can actually search and find people nearby using geolocation inside Telegram. There's a new OSINT opportunity though in Telegram that came about last November. November 2023, they launched a feature called Similar Channels, which allows you to see for each channel on Telegram, they'll show up to 100 other quote-unquote similar channels, so channels that are similar to it. And the way that similarity is determined is whether the channels share a user base. So channel A and channel B, do they have the same users in them? If so, they're considered a similar channel. And you can see a screenshot up here showing just a sample channel and where to find the similar channels button there. Okay, and this is in both the the web version, the desktop version, and the mobile OS version, iOS version. So as soon as I saw this feature come out, I got really excited because I've been doing this for a long time. And this feature reminded me of one that used to be available in Facebook, but they took it away. Find me outside to find out why they took it away. But they took away this feature back in 2018. And I've missed it because it was really, really, really handy for finding what groups were in common with each other, what groups were similar, and what groups shared a membership base. So Facebook used to offer API access to their group membership roster. So if you make a group in Facebook, it would allow you to download the entire roster. And from that, you could then figure out what groups shared the same membership. So I used this way back when to create innumerable network graphs. I mean, just hundreds of them. But one of the most common or the most famous was this one, which showed the circles on the network diagram are each Facebook group, and then they're connected. The edge, the connection line, shows the ones that share membership. So overlaps, right? Person in one circle is the same as the person in another circle. And what I used this for back in 2017-18 timeframe was to explain the Unite the Right event that was in Charlottesville, Virginia in 2017. You might have heard about it. It was a big neo-Nazi march, basically. And so what I did was use the information inside of Facebook to understand the groups that sent people to that rally. So, important caveat when we're comparing the way Telegram's new similar channels feature works with something that we might be familiar with, like Facebook from the past, is that Telegram does not show you the similar channels that you've already joined. So just know this going in, you're going to need a fresh, if you want to really see all the similar channels for two sets, you're going to need a fresh, clean Telegram that has hasn't joined anything. Right? Either that or you'll have to leave all the channels you've joined. And if you're like me, you've joined like 1,000 channels, so that's kind of awkward. So create a fresh Telegram, a nice clean one, right? In this way, the Telegram similar channels are really more like suggested channels, right? Because if you're already in it, it's not going to show it to you, even if that channel might be similar to the one that you're looking at. So they've actually created, I think it's more like a recommendation algorithm, really. It's a little bit different than just similarity. And that in that way, it's also different than the old Facebook method too. Okay. So on the left-hand side here, you can see a screenshot of a clean Telegram. I look at a channel, it shows me 4 similar, right? On the right-hand side, you can see one I've already joined. I've already joined a bunch of channels in that account, so it's not showing me the ones that I'm in. The list is smaller. Right, so if you try to do what I'm going to show you with the Telegram, that you've already joined a bunch of things, you're not going to get full results. I made this mistake early on because I didn't know how this worked. All right, so the code for what I'm going to show you today is out on GitHub. I know you probably don't want to scan a QR code, which just goes to GitHub, the link that's shown there. It's just on my public GitHub account. And this code base includes the SQL creates, assuming you have a MySQL database. It's about 5 tables. One of them's a jobs table. There's a couple tables for tracking the channels themselves. And then there's the sort of the big table, which is the one that maps which channel is the other channel's similarity partner, so the pairs. I also give some sample SQL queries, and those are labeled out so you can, run some samples and kind of get used to the data, so you're not just jumping in there blind. And then the code, of course, since it's just one Python script, not the end of the world, but it's got about 5 or 6 functions in there. And what you're going to do is provide a seed list of channels, and then it will go out, and I'll explain the methodology where it goes and grabs the similar channels and then pops them in the database, and then we can query them. All right, so my experiment that we'll talk about today was with US-based extremist groups on Telegram. We use a snowball collection method. So this means I give a channel, it goes out and finds the similar channels, and then each of those, it finds the similar channels, and each of them, and so on, right? So you can get really big, really quick doing this kind of method. Each of those rounds is called a generation. So we start with the first generation, and then their children, or the second generation, and then third, and so on. I only keep the ones that are new. So if I've already seen a channel, I don't need to write it to the database, but I do write the pair. I do write the fact that it's somebody's similar channel. I started with a seed list of 335 channels from a variety of different extremist and hate ideologies, the ones that we study. But you could start with whatever. You can even start with one channel. You could even start with your own channels that you subscribe to, but keep in mind that you'll only receive similar channels that you're not already in. So be aware. All right, so with my experiment, I did 3 rounds of the snowball to start. I mentioned generation 1 was the list of 335, right? So that's my seed list. And then generation 2, I ended up with 2,652 new channels that it discovered. So those 335, I discovered 2,600 new ones, basically, that they were connected to that I didn't know about. And then from there, another generation, it took all those middle ones, right? And then all their children. So I'm up to 28,000 nodes real quick, and over 220,000 relationships between those. Okay, I know. And I could have gone on, right? Somebody asked me yesterday when I was talking about this in a coffee line or something. They said, does Telegram have rate limiting? Oh yes, they absolutely do. So you will be rate limited. I wrote my code very poorly too, so I rate limited myself by not parallelizing it and doing it properly. But yeah, you will get rate limited. So it took me about a month actually to run this through the experimentation, rewriting my code, screwing it up, trying again. So you'll benefit from, my code's already been kind of fixed a little bit. Hopefully it still works. But yeah, so be patient, and you probably will get rate limited. And then once I've got those nodes, my groups, my similar channels, and my edges, so the relationship between them, I'm going to mock those up in a social network diagram using Gephi. So I'm going to show you how that works too. Okay? I don't have code for that. It's mostly just a software package, but it is free. And I'll show you how I modeled it in there, and then it's pretty straightforward to use. All right, so version 0 of my network, I've got the data all loaded into Gephi. You can see the ugly network there down at the bottom. I used Forest Atlas 2 layout. If you've ever done social network mapping, that just means that it throws all the circles, all the channels down on the graph, and then starts to rearrange them to put the similar ones together on the map, right? So you can kind of start to see some clusters here, but it's pretty messy. We call this a hairball. It's like, nobody would want to read this. I don't really learn much from it. It's not very good. So we're going to need to keep going. We're going to need to do a little more work here. So I'm going to start with some pruning strategies. This just means removing nodes so that I can make more sense of what I have. So here's some techniques that I tried, and I'll tell you the ones that worked and the ones that didn't, and why they worked or didn't. So the first thing I tried was language detection. I'm interested in US-based groups. They primarily speak English. So I thought, well, why don't I bet I've got a lot of junk in here that's not English, and I'm not interested in those groups, why don't I just take them out? And if later I want to do an international-based project, I'll rerun it again with those and figure it out later. So I wrote some Python code to detect the languages. I used the lang detect, unit decode, and lang codes for this. And so basically what I did was just take the title of the Telegram channel and then the description of the channel, and I just detected what language it was and threw out the ones that weren't English. Unfortunately, I had a couple problems. One was most of the titles and descriptions were in English, and then the other problem was a lot of them weren't detected properly. So it was in English, but it called it Turkish or something. Yeah, so it just wasn't very effective. I also thought for a while about taking a sample of the postings on the channels to like see if those were English, and then I thought, I think I can do better. So I just tried some other techniques. I was being a little lazy. The next thing I tried was unpopular channels. So I thought, well, why don't I just prune what we call chandeliers or pendants? These are channels that don't have enough people pointing to them. So they only got suggested by 1 or 2 other channels. They're not very popular. So I thought about throwing those out, and that worked a little bit better. I'm going to show you the results of that in a minute. The other thing I did was to use network metrics to actually, that's my hacker tracker telling me I'm supposed to be somewhere else. Don't worry, I'm not leaving. So the next thing I thought was using network metrics to prune out the channels that have what we call like poor scores. They're not influential. They have low betweenness. They look like an island. They're like being weird. They just don't like work very well with the network. And so I'm going to show you some examples of that too. The 2 sets of those that I pruned out right away from that prior diagram that you saw, and in fact I'll go back real quick to that. See up at the top there, there's like an island there that's kind of off to itself, and then there's one on the far right hand side. So those 2 I pruned out right away. And here's the version 2 of the network. It's still kind of gross. Don't worry, we're going to make it better. But at least now I've got a cohesive blob, right? I don't have things like way out. And I'll just go ahead and tell you the 2 that I pruned out were the Telegram branded channels themselves. So one was like Telegram tips or something. Also, that's a huge channel. It had several million members in it. So it was messing up my sizing too, because it was the largest ball and it made all the other balls look small. Then the other one that I pruned out was like a very interesting but irrelevant to me collection of Ethiopian religious channels, which was the one that was up on the far right. So I got rid of those. And now we have a cohesive blob that I can do a little bit more with. So some structure, but I'd like more. The first thing I did here to try to produce more structure in the diagram was to colorize the network. So here you can see the black circles are my first generation. So this is the seed list that I started with. This is the 335 nodes that I began with. And then everything else, all the pink dots, are the second generation. So what I'm looking for here is to make sure that my seed list is pretty well spread out. I don't want like all my seeds in one section. I want them spread out and like distributed, dispersed. Because what I'm going to do next is start to look at what I think is going to be the underlying structure, which is ideology. And so I want to make sure that I have a good sample. When I colorize the network for ideology, it looks like this. So what I've done here is use a Louvain neighborhood finding algorithm. This is inside Gephi. You don't have to write it. I didn't write it. But it's just inside there, and it will help you find the natural clusters of channels that go together. So you can tweak this to have more or less neighborhoods. Here I used about 7, and each neighborhood is a color. So what this is doing, what the algorithm's doing is it's going, okay, I'm going to physically put the dots that go together, and then I'm going to colorize them, and I'm going to look at separating the colors based on what's dissimilar from each other. Right? So it's both doing similarity to cluster and then dissimilarity to separate the colors. And so this is useful because it's going to show me the kinds of channels that seem to go together. And then what I can do is actually investigate by putting the labels on. So, this circle is Proud Boys, and this circle is, some other white power group or something. I can put the labels on and then determine what those clusters mean. Like what do they represent? So what is orange? Who are those groups? What are they about? When I do that, and this took a long time because I had to investigate the actual labels for the dots in every single one of those neighborhoods. I see that yes, the neighborhoods actually are pretty accurate. I've got a cluster of QAnon groups over there on the far right. I've got a cluster of MAGA, sort of Trumpy style groups right next to QAnon, go figure. Not an accident. Then I've got a bunch of Proud Boys groups that I've colorized gray, groups that are into sharing sort of extremist memes and stuff. I've got some white power groups, Groypers, which is a US-based sort of anti-Semitic group, some traditional Christian groups, other white power groups, and those actually were interesting. I had 3 white power clusters, but they were separated out by the tactics that the groups take part in. Now this required some domain knowledge to understand, right? I had to know what these groups were about and what they're into. But the social network process told me that there's 3 different things going on. You figure out what they are. So then I can go in and be like, okay, it looks like this group is different than this. What's different about these 2 clusters? Oh, one of them's really into media and the other one's into showing up on the ground and beating up people or whatever. There was an interesting cluster down at the bottom, the one there labeled geopolitics. This one was pretty surprising. It's also got I don't know if you can see this, but it's got the largest node on the diagram. It's got the largest. So the nodes are sized here by how many people are in the channel. So that big green pea down at the bottom looks like a vegetable or something. That's actually a channel called, I forget what it's called. It's a Russian channel, and it's a media channel. The other green circle nodes in that green area are channels devoted to like geopolitical intelligence, and they're mostly connected into the MAGA wing and the memes and the white power wing. So it's kind of an interesting finding. I was not expecting that at all. In my seed list, I only had 1 of those channels, but by just including the one, all the other ones, you find out who they all pointed to and who was members of all these other things that I didn't even know existed. All right, the next thing we're going to do to try to make sure that we've got a good understanding of what's happening in this map is we're going to calculate what's called network metrics. Now, I could do a whole talk just on this. This is like the math stuff that's underneath that drawing that you saw. So underneath the actual network, why are those 2 dots next to each other, right? So this is the math that's going into that. I found through a lot of painful trial and error that some of the simplest and easiest to understand network metrics were the most effective here. So I didn't actually have to do a lot of fancy social network science. Probably the most useful metric was what we call the in degree. So this is how many other channels are pointing to you. How popular are you? How many other channels name you as their similar channel, right? That's called the in degree. And just by taking my list of channels and sorting it, highest in degree at the top to least popular, lowest degree at the bottom, I could immediately see that, for example, this thing called Zoomerwaffen had 564 other channels pointing to it and sharing members, but it only pointed to 60 others. So it was very popular despite not particularly pointing to a lot of other channels. It could have pointed to up to 100, remember, but it only pointed to 60, but 560 people pointed to it. So that's kind of interesting. Another metric that we can use, this one's a slightly more of a mouthful, but it's called the eigenvector centrality. And this one you can think of like the way Google works. I don't know if you know how PageRank works or used to work, or at its simplest how PageRank works, but essentially the Google search relevance algorithm says, I'm going to rank you higher the more important pages you point to and that point to you, right? So we have a similar thing going on here. The channel gets a higher score. It's normalized between 0 and 1, so 1 is the highest you can get. It's right there. I'm going to give you a higher score the more important channels point to you. So we see whatever that top Zoomerwaffen or whatever, that one still got a pretty high score there, but we also see that this Midnight Rider channel actually got a perfect score there. If you look at that channel's placement on the graph, it's right in the middle of MAGA world. It's got a lot of channels pointing in. It's doing a lot of heavy lifting. That was another channel that I did not have in my mental model, but this social network analysis told me that I was wrong. It told me I was missing something, and I had to go check this out. Once I went there, I realized, oh yeah, that's a really important channel. I did not even know this person, but they have a ton of followers and a lot of influence. So I was able to correct my own mental model just by looking at the numbers. All right, the next thing we're going to do, and this is probably the last thing we're going to do, is we're going to look for suspicious things going on. So I'm always wondering how people are gaming Telegram, right? It's full of scams and all this nutty stuff. So I started seeing this in my graph too. I saw weird stuff, like weird shapes that shouldn't be there, suspicious things. For example, On the screen, you can see, if you zoom way in and add labels, you can see a cluster of channels that's only connected to the Columbus Proud Boys. Who are the Columbus Proud Boys? Well, Columbus, Ohio, they have a Proud Boys chapter, apparently, I don't know. And here's, I don't know, a handful of other channels that have nothing to do with anything. There's really random names. All they do is connect to each other and then to the Columbus Proud Boys. Like, that's clearly suspicious. What's going on there? Sure enough, some of those channels have now had their similar channels feature disabled. They were basically inauthentic channels. They were fake, and they were just going and joining random stuff and trying to, either if it's a chat, they were trying to create conversation, or they were trying to appear on someone's similar channel so that you would click in and join them. Like, they were just not authentic at all. Here's another one that I found that was in the blue, the sort of white power area. There was a channel for a white nationalist podcaster. And when you hover over, you see that there's this cluster of oddly named channels that pointed to it that seem to have nothing to do with that mentality or mindset. And when you go to the channels, it's all just like women sort of trying to flirt with you type stuff. Yeah. Here's another case where there was very clearly in the network diagram a sort of archipelago, I called it, like a little island chain of channels that sort of did nothing but point to each other and to one controlled channel. All of those channels had names of US political figures, but they were spelled weird or in the reverse order. So instead of being like real Donald Trump, it was Donald Real Trump, that kind of stuff. So when you click in, I discovered that every single one of the channels in that list was purchased. The username was purchased using the Telegram's username purchasing feature, where you can just basically buy money to have that name. So they were all created, usernames paid for, and then joined each other, had a control channel that was managing them, and then that channel joined legitimate channels. And this whole scam was essentially designed to funnel people into grifts and Holocaust denial and other things like that. So as soon as you click to follow that quote unquote similar channel, you're presented with, the opportunity to buy Jesus coins and, whatever all else. Trump stickers or something, I don't know. So it's just people trying to use the structure of Telegram to make a buck, right? So, but again, I wouldn't have discovered that if I hadn't modeled it with the social network and then looked at the pattern. All right, so the OSINT wrap up, and we'll probably have time for a couple questions if y'all have any. The similar channels feature in Telegram can expose which channels have similar users, which channels are the most popular for a given user base, which channels are being used for inauthentic behavior within a group of channels, which ones are the fake ones, which channels are conducting inauthentic behavior, so running scams and trying to glom onto other more popular user bases, and then which channels are being targeted for others to conduct that inauthentic behavior. So you can see the marks, right? You can see the ones that they're targeting. All right, that is my talk. Thanks for coming, and if you have questions, I'd love to hear them.